Okay, we're going to be doing the notes for Chapter 5, Section 1. There are actually, 2 days that we're going to be spending on this. We're graphing a new type of a function, and it's the quadratic. You can see the quadratic function here, f of x equals ax squared plus bx plus c. It's going to be called a parabola. A parabola is a very different type of a shape than a line. We've only been graphing lines and absolute values. If a is positive, our parabola opens up. It will look something kind of like this, kind of like a U shape that is going to be opening upwards. If a, that is the number in front of x squared, is negative, the parabola opens down. And that means our parabola would look something more like this. Obviously, a parabola has a highest point or a lowest point on it. That point is called the vertex. The vertex of a parabola, like I just said, is the highest or lowest point on the curve. It is a point, so there will be an x and a y coordinate. Another major feature of a parabola is that it will be symmetrical. An axis of symmetry is a vertical line. It's a vertical line that contains the vertex or passes through the vertex. And it's going to go right down the middle of the curve. The equation of that line, remember we've talked about Vux all throughout the course. Vux is going to be x equals some number. That number will be opposite b all over 2a. Again, what's so incredibly important is that the a and the b that we're talking about, or the opposite b, is referring, in fact, to this number in front of the x. The a, likewise, is the number in front of the x squared. So you take opposite b over 2a, and that will be the value that we have for the axis of symmetry. That opposite b over 2a, again, is very important. It's going to be the x coordinate of our vertex. And a lot of times we will write this as h comma k. What you'll see me write quite a bit today in the notes is that x coordinate of the vertex is opposite b over 2a. Well, let's go ahead and jump into a graph of a curve. For example 1, if we were to graph this, just getting started, a would equal 1. There's a 1 out in front of x squared. B would equal 2. And c would equal 4. But what we're asked to do is to find the vertex and the axis of symmetry. You want to have memorized that h is equal to opposite b over 2a. We're going to do this for many, many problems. B is 2, so we'll take opposite of 2. Our a is 1. 2 times 1 is our denominator. Well, just simplifying this, negative 2 over 2 is going to be negative 1. That value of negative 1 is extremely important. Like most curves that we've graphed before, we're going to plot points. And we're going to build a table around that value of x equals negative 1. Now what you do always is you take that x coordinate of your vertex and you go one step bigger, or add a 1 to negative 1, you'll be at 0. Get one step smaller than negative 1, or subtract a 1, and you'll be at negative 2. Likewise, we could also add another 1 in addition to that 0. Get one step bigger than 0, and also get one step smaller than negative 2, we'll be at negative 3. And if you fill in this table, you're going to be in real good shape. You will have a graph that would quickly be able to be plotted. But of course, we just have to do a little bit of work and find out what these y values are. This is where a calculator can definitely help you out. we started off with that -1. That's what began to build our table. So tell you what, let's just plug -1 in for our x value. Of course, we could work this out by hand. It might just be a lot more quick to let your calculator work this out for you. You should get y to equal actually a 3. Plugging in a 0. If you do that, of course, this is probably more quick to just work out without a calculator. You can see very quickly that at 0, your y value would equal a 4. Tell you what, let's plug in -2. Again, watch the parentheses as you're typing this in. Anytime we're plugging in an x value that's negative, you definitely want to plug in parentheses with it. And sure enough, if you worked this out on your machine, you would get y to equal 4. Now, by the way, just as we saw with our absolute value graphs, we have symmetry. We're going to see that those y values of 4 are getting doubled up. Do always check that that is the case. If you were to make a mistake on one, you'd be able to have a safety net and check the other one to make sure that you're in agreement. Let's plug in a 1 as well. This might be one of the easier things to check. Plugging in a 1, I think you can see quickly you will get a y value of 7. And finally, let's also plug in a y value of -3. Remember to use those parentheses. With the calculator, this just becomes a quick routine. You're going to be able to quickly see that y would equal 7 as well. Now again, the symmetry issue is extremely important. You're going to always see these y values getting doubled up. Now, where we built our table around is our vertex. They're always going to ask us to plot the vertex. That'll be the point -1, 3. Our axis of symmetry, well, that is a line. It's the line x equals something. It's always x equals the x coordinate of the vertex. So it will be x equals -1. And let's go ahead and plot these points, starting with the vertex. -1, 3, go 1 to the left, up 3. 0, 4, don't go left or right any, just go 4 steps up. -2, 4, go 2 to the left, go up 4. 1, 7, 1 to the right, up 7 steps. And finally, -3, 7, 3 to the left, then up 7 steps. You can see your parabola taking shape. You know, even before you start graphing, that it had to look something like this. The axis of symmetry is a vertical line that we can draw in at x equals -1, and that would be a line that we could fold our parabola over. Our curve would fall on top of itself, and as we saw with the absolute value curve last chapter, those y values that were the same are indicating that those are symmetrical points. Well, real quickly, let's go to number 2 and work that out. We won't even bother with number 3, but with number 2, let's remind ourselves that a would equal -2. B, the number in front of x, would be -4, and c would be 3. Again, a is always the number in front of x squared. If it's a negative, we must keep it negative. So our vertex, h, like I said, opposite b over 2a. Well, opposite of -4, down below we'll have 2 times -2. -4 is a 4. 2 times -2 is -4. 4 divided by -4 is -1. What does that tell us? Well, very importantly, we will build our table around the x value of -1. Let's get one step bigger, which is at 0. One step smaller. Another step bigger than 0 is 1. Another step smaller than -2 is -3. And at this point, we are plain and simply going to plug these x values in and find out what our y values are. Of course, you can start anywhere. But let's start with our vertex. We're going to plug in -1. And again, you want to have your calculator with you. As always, when you're plugging in x values, keep them in parentheses. The calculator will be able to get you a very, very quick answer. Hopefully you would agree that that answer is 5. So here you get y is equal to 5. Let's go ahead and plug in a 0. You plug in a 0, you get very simply -2 times 0 squared minus 4 times 0 plus 3. It won't take you very long to get 3. Let's plug in -2 as well. If we plugged in y equals -2, well, this would be a situation where, again, you want to make sure that you're using parentheses. If students are making mistakes here, parentheses are almost always to blame. But what you're going to see very, very quickly is that you will get an answer of 3. Again, that symmetry is so very, very important. You're always going to see that y value get doubled up. Plug in a 1 real quickly. Well, -2 times 1 squared minus 4 times 1 plus 3. Well, you're going to see very quickly that you'd get a y value of -3. Don't just assume that when you plug in -3 that would get you another y value of -3. Do check it. If you ever quickly make a mistake, this is your chance to check it. But hopefully you would see very quickly that you do in fact get a -3. Well, we're almost done. Let's see. Our vertex here is going to be -1, 5. Our axis of symmetry is going to be x equals -1. And then we just have to plot our point. -1, 5, 1 to the left, go 5 steps up. 0, 3, just go 3 steps above the origin. -2, 3, 2 to the left, and then 3 up. 1, -3, 1 to the right, 3 down. And then -3, -3, 3 to the left, and then 3 down. As you look this over, I hope you could quickly see that there's a definite parabolic or parabola shape. Right down the center of the curve is your vertex. Okay, really that's all we have time for today, so we won't even worry about number 3. But hopefully this is enough to get you started. Just to recap, always find A, B, and C. Find out what the x-coordinate of your vertex is. It's always opposite b over 2a. Build your table around that x value. Go 1 step bigger, 1 step smaller, 2 steps bigger, 2 steps smaller. And you'll always see symmetry as you're building that table. The end result will always be a parabola, a U shape that's either opening up or down. And you'll know whether it opens up or down via the A value. Look at this last problem we just did. A was negative. We could immediately know our parabola opens down. Well, I hope this helps. Best of luck to you.